Good morning students. In the CET problems session, question number 130, next question. In this a charged capacitor, fully charged capacitor means fully charged capacitor formula we have to take is Q in terms of what you take, full charge. If not full charge also, procedure is similar only. Whatever charge is there, that will be can be utilized later. Fully charged capacitor actually is given. I change this to just charged capacitor of capacitance C is discharged, means charge is coming out, discharged through a resistance wire. It is inside the thermally insulated block, means heat is not going to the outside atmosphere, just whatever heat is produced, just heating the material it means. So on heat what happens, the material gets heated up, its temperature rises. So block is actually insulated so that the metal temperature is increasing. Metal mass is given as M, mass is M and specific heat capacity is S, and the temperature increase is delta T. Find the potential difference of the capacitor V we have to find out. This V capacitance is C, charge is Q. Okay, and Q data not given. So options are given such that only these terms are there. C is there, S is there, M is there, and asked is potential difference V equal to how much. Only in terms of this we have to take this relation. So Q not given, not required. So whatever the energy of the capacitor has the heat across the resistance material. Whatever is the coil given, whatever given, that wire has the resistance. Across the resistance, heat is produced. So whatever the energy stored is equals to heat energy. Heat energy formula, mass into specific heat into change in temperature. Heat given or taken by any object in the thermal properties you learn first year topic. Heat given or taken is equals to mass into specific heat into change in temperature. So you want to take here is energy of the capacitor is U equal to half CV square, because you are getting C and V, this is capital letter, one relation. And heat energy produced is nothing but equal to, that is we take it as a Q generally, but Q confused with the charge, I am not giving the symbol for it, equal to mass into specific heat into temperature change. Temperature change. That means this equals to M, specific heat symbol is S, sometimes they will give the C symbol for specific heat, small s actually, symbol for specific heat, temperature change is delta T. That means this equal to this, you have to find out the potential difference V how much. Therefore, U equal to half CV square is equals to heat energy, that is MS into delta T. You are asked to find out the potential V. V equal to 2ms into delta T by C under root is the formula. This is a potential or potential difference. It is just concept related problem. Next is 134. Next question is 134. Charge Q equal to 10 to the power of minus 3 microcoulombs. A charge 10 to the power of minus 3 microcoulombs is at a point 0, 0 in the xy plane, xy coordinate system. That means it is at the origin. This 0, 0 means it is at the origin. Next, 2 points A and B are situated at 2 points A, B are situated at root 2, root 2 and 2, 0 respectively. Find the potential difference between A and B. Find the potential difference between points A, B. Find the potential difference between A and B. So here points positions you check up, this x axis, y axis, origin. So capital Q, let us take this charge Q is at the origin. This is Q equal to 10 to the power of minus 3 microcoulombs. 2 points are given. That is, this one is at the origin. Okay, and 2 points are given. One is A, this is A, and this is B. A is at root 2 coordinates. Means you take this point. This point is A. What are the coordinates for this A? Is x coordinate root 2, y coordinate is also root 2 meters. So this is supposed to be equal to root 2, and this is also equal to root 2. So this is root 2, this is also root 2. Or else you can take here only meters. And another point, B is at 2 comma 0. This is x coordinate, y coordinate. So take it as 2 units. This is a root 2. Root 2 is nothing but equal to 1.414, means less than 2. So other point B is given at 2. So it is beyond this point. You take it up. That is, this is B. Coordinates 2 comma 0. So this unit is 2 comma 0. You have to find the potential at A, potential at B. You have to take a VA minus VB. What are the coordinates are given for this? But what is required is the distance from this point to this point. This is R1 or RA I will take. What is RA becomes? This is hypotenuse. If A sides are there, no right angle triangle, this must be equal to A root 2. If this is A, this should be A root 2. But already root 2 is there. So this distance becomes equal to, RA becomes equal to A root 2, means root 2 into root 2 is 2 units. Okay, this is 45 degrees. Like that also you can find out what is the value of hypotenuse. This is RA. What is RB? Only x coordinate, y coordinate is not there. So this is RB. RB is nothing but equal to 2 units. Okay, find out the potentials at A and B. What is VA? VA is equals to that this charge Q by, because of this capital Q only, the potentials 4 pi epsilon naught into RA. Okay, this is nothing but equal to 1 by 4 pi epsilon naught into Q is 10 to the power of minus 3 into 10 to the power of minus 6 microcoulombs at origin, and A, this is A, this is B values. Find PD. Here this RA is nothing but equal to how much is 2 units. This is minus 9, 1 by 2 you will get a 10 to the power of minus 9. VB is how much? And one more thing, in the options if they give 0, if options are 0 in the competitive exams, no, you have to check up that possibility 0 also may be there most probably. Okay, then you can check up in short also, or you calculate completely also, doesn't matter. This is minus 3, minus 9 by 2. This becomes equal to 1 by 2 is 0.5. This is 10 to the power of 9, 10 to the power of minus 9. This will be 0.5 volts. Next is VB, if you check up. VB only distance is 2 units. Only 2 units. So we'll get is 1 by 4 pi epsilon naught into Q by RB, which is also 9 into 10 to the power of 9 into 10 to the power of minus 3 into 10 to the power of minus 6 by 2. But checking up the values also we can check up this constant Q same, R same, and then potential also same. This is also equal to 0.5 volts. So potential difference between A comma B points is delta V is VA minus VB. 0.5 minus 0.5 equal to 0. When options are 0, you can check up by the formula only, by substitution, whether the values are same. When values are same means no need to work out more, because Q same, R same, automatically potential also same, potential difference becomes 0. Next 135, you just go through that. When vector form, charges are same, but same charges change the positions within that system. Then potential do not change, because potential is a scalar addition only we take. But vector is what electric field vector direction is important. So if the charges are changed in position, electric field direction can change. Magnitude may be same, directed change also we should not say vector, it is a constant. That you check up. Next is 136. Similar problem we had done already before. Next 136. But once again we will work out the similar one, just small variation is there in this. Potential at a point X in micrometers due to some charges situated in the x-axis is given by potential at a point x. Potential is given as V as a function of x. In the bracket x is indicating this V x. If they mention it is not V into x, it is as a function of x, means potential depending on the distance. As the distance changes, the potential is changing. It is called a function of x into equal to 20 by x square minus 4 volts. Find the electric field at x equal to 4 units. Find electric field at x equal to 4 micrometers or 4 units. This was previously asked question. Electric field E equal to minus dV by dx. E equal to minus dV by dx, which is minus d by, here in terms of the x, in terms of x is only variable, not y is not there. So take it as dV by dx, d by dx of 20 by x square minus 4. This denominator you can take it to the numerator. So this becomes equal to minus d by dx of 20. 20 is a constant, you can take it out also. So I will take it as a 20 minus 20 into d by dx of x square minus 1 to the power of minus 1, x square minus 4 to the power of minus 1. Differentiate that part. So in this what you take is this whole quantity is one variable. Okay, but it's a 2 times derivation you have to take. What you take is first differentiate the whole quantity and differentiate inside the bracket part. Only x square differentiation. X to the power of n differentiation is nothing but equal to differentiation of x to the power of n by dx equal to n into x to the power of n minus 1. If any constant is there, don't take that out. Only constant is there means differential of constant is 0. Okay, if any constant is there along with this variable x, take that out as it is multiplication. So this 20 is a constant now taken out. So differentiation of this part only take it out. First differentiation of this whole quantity. Imagine this as one y and differentiate this in terms of x is there inside. So this whole thing is n. N is minus 1 here. Minus 1 into this whole thing to the power of minus 1 minus 1. Okay, minus 2 it becomes. And inside part differentiation of x square becomes equal to 2x. The term is, next term is E equal to minus 20 as it is you take. The differential part is x to the power x square minus 4 to the power of minus 1 minus 1 into minus 1. That n into x to the power of n minus 1. So we will get a minus 1 into x square minus 4 into the power of minus 1 minus 1. Next into internal inside the bracket, no, that part you take it. That is nothing but differentiation of x square is 2x it becomes. This is minus into minus is plus 20. This is to the power of minus 2. Take it to the denominator again. X square minus 4 whole square it becomes into 2x. Into 2x. 2 into 20 is 40x you will get. This is equals to 40x plus only by x square minus 4 to the square. But what you asked is x equal to 4 units. If x equal to 4, substitute the value into this, then E becomes equal to what is that? If x equal to 4 units, then what you get electric field is 40 into 4 by 4 square minus 4 whole square it becomes. This is nothing but equal to 40 into 4 is 160. Okay. This is 160 by 16 minus 4 is 12. 12 square is 144, which is equals to, check up the options in that. Ten by 9. This is micro units, so you will get the result as in terms of the micro only. Sixteen nines are 144. So 16 10 times, or else 2 it can take division is 9 times. So we'll get is micro volt per meters. 10 by 9. That is option. Next, I want to make a jump. Next is 139, and mostly diagram problems are very important one. They will repeat it, comes as it is also. What I am giving you, small variation may be. The next page problems are very, very important ones. One 39. Charge Q is placed at each of the opposite corners of a square A. Charge Q is placed. Charge Q is placed at each of opposite corners. At each of opposite corners. Only two corners are there. That means two charges are there which are of the same values. Opposite corners of a square. Charge and another charge. Q is placed at each of the other two corners. Charge Q, small q it is placed at other two corners of square. If the net electric force on Q is 0, if net electric force on Q is 0, find the ratio Q by Q, small q by capital Q or capital by small q, that you have to verify. This thing you have to find out. We have the square. First charge is capital Q, another charge is small q, and it is a square corners. Capital Q, opposite also capital Q, but remaining opposite corners small q is there. Okay, and on this capital Q, force are there. Between these two, one force is there. It can be attractive or repulsive. Net force is 0 means some should be positive, some should be negative compulsory required. So these two are same kind. These two are same kind. So one kind is positive, other kind is negative. Whatever, we just want to find out the ratio we have to find out, because force is 0. Net force is will never be 0. Net force will never be 0 if you have taken all positive charges. Okay, unless if you take the two charges exactly midpoint, net electric field is 0. Null point can also possibility is there for like charges, but otherwise not possible. So on this charge, the forces between these two, I will take it as F12 or F1, and between these two F2. One more is there, this one is F3. If these two are attracted, this must be repulsive, that is F3. So resultant of these two must balance F3. This is F3, but these are Q same type, no. F1 F2 will be either up or repulsion is there, means both should be downwards. I am thinking that these are positive one kind, these are negative, then automatically attraction will be there. Or if you take these two negative, these two positive, also attraction will be there. So I am imagining like that, but not necessary to be like this. Just know that these charges are same, these charges are same, force will be same. Okay, side length we imagine AA. So what is hypotenuse becomes equal to A root 2, it becomes, nothing is there at the center, A root 2. Okay, and next is the net force you have to find out. In that net force, first you find out the resultant of F1 and F2. Because these charges are same, distance are same for this F1 and F2, so F1 must be equal to F2 in magnitude, not in direction. What is the angle? 9 degrees. Whenever the angle is 90, the resultant becomes equal to, when two vectors are same values, but angle is 90 degrees, no, resultant will be making 45 degrees, middle point, one thing. Second thing is F1 root 2 it becomes. F1 equal to F2 in magnitude means F1 root 2 is the resultant, that will be in this direction. This resultant of F1 and F2 will be in this direction, that is F12 I will take. Okay, and in this must be equal to this equal and opposite direction to get the total resultant 0. So I will take the charges. This is A, B, C, D. Similar problem we have done before, but it is slightly different. Previously we have taken the one more small q at the center only, but here it is different case. I am taking this between CD and AD, for AD and CD side charges. So what I get here is F1 equal to F2, magnitude only I am taking, is equals to Q into Q by 4 pi epsilon into distance square, that is A square we take. But F1 magnitude equal to F2 magnitude, and theta is how much between these two is 90 degrees. Therefore, resultant of F1 and F2 is F12 equal to F1 root 2, and F1 is equals to F2 you will have. F1 is this value or F2 is the same values. Next, we take a BD. For BD, BD force is F3. Both are capital Q's. That is F3 is equals to 1 by 4 pi epsilon naught into Q square by distance square. The distance is A root 2 whole square. That means A square into 2 it becomes. It is nothing but equal to Q square by 4 pi epsilon naught into A square as it is into 1 by root 2 square means 1 by 2 it becomes. So net force is 0. When net force is 0 means this plus this. Which one you have to take? F1, F2 not required. Resultant only you have to take. What is the resultant? F1 root 2 is the resultant. So this and this last ones. This one and this F3. Total resultant must be equal to 0. But F net force is equals to F12 plus F3 equal to 0. F12 is nothing but equal to F1 root 2. This is nothing but F1 root 2 plus F3 equal to 0. Taking one to the other side becomes a negative. That we can take later. Next, what is the F1? We have taken this already. This is F1 and as well as F2. This is F3. So F1 root 2 means QQ by 4 pi epsilon naught into A square plus F3 this term Q square by 4 pi epsilon naught into A square into 1 by 2 equal to 0. 1 by 4 pi epsilon take out common and A square also take out common. Take it to the right side, it becomes equal to 0. Okay. Next left out term is, so we will get the relation from this. QQ is equals to, take it to the right side, minus Q square by 2. One Q also cancels. Got to 2Q. 1 minute, I did somewhere mistake. Somewhere I did mistake. F1 root 2 plus F3 Q square square. Here I missed the term point, this F1 root 2, here only F1 I have taken, it comes is root 2 comes here, one term. So F1 root 2, this is F1 into root 2, this is F3, okay, remaining part is correct, only root 2 term I missed here. So here you will get is, here left side you will get root 2, that means QQ root 2 equal to minus Q square by 2 you will have, one Q cancels. So Q is equals to Q by Q we want. Q by small q is minus 2 root 2 is the answer for us. Ratio do not have units. Next question 147. This page problems and even next page problems are very important, including because the diagrams points. For all competitive exams, they will be coming repeatedly. 147, in the given circuit, find the charge on the capacitor, condenser means capacitor of the 5 microfarads. In figure, find the charge on 5 microfarad condenser or capacitor. Here you are given the circuit diagram, one capacitor. Here another capacitor and the battery, one more capacitor and then battery. Battery is 100 volts plus minus, and capacitors, this is 4 microfarads, and this is 3 microfarads, and it is 2 and 5 microfarads. This is 2 microfarads. You are asked to find out the charge on this 5 microfarads. I will take this Q is equals to how much. Okay, I will tell you the formulas to find out the charges on all capacitors, even though they asked only for 1. Okay, here 5. This whole thing is 1 capacitor will take, and this setup is parallel to this. So whatever voltage 100 is there, same for this and also for this combination. So for the 5 microfarads, what is the charge? I will take this as a C1 and the charge will be Q1. What is Q? C equal to Q by V. V is same here for parallel combination. Q equal to this C1 into V. You can find out easily for this. Okay, V is how much is 100 volts. Next is this, I will take it as a C3. 3 corresponding to, okay, this symbol is 3. This is 4 microfarad. Now let us take it as a 4. This is 4 microfarad. C4 into V. What is the charge on this is depends on this voltage. I will take the voltage across this as equals to V3. And this whole set is parallel. Parallel means 2 plus 5 becomes equal to 7. So voltage across this, I will take it as a V2. This is V3 and this is V2. This voltage is V2 5. 2 and 5. This is going to be V3 microfarads. So charge on this becomes equal to, I will take it as Q3. What is the Q equal to is? Q equal to CV. This C3. So C3 into V3. This whole combination is 5 plus 2. 5 plus 2 is 7 microfarads. 5 plus 2 is 7 microfarads. 7 microfarads is, I will take it as a CV25, and this whole thing is equal to C25 microfarads, and this voltage is where to find out. The charges will not be same on this and this because they are parallel combination. Series charge is same for capacitors, parallel charge is not same, voltage is same. So V25 is same for these two. So this is equal to only top portion I am taking. This is one capacitor, this is another capacitor. This is 7 microfarads and this is 3 microfarads. This I will take it as a C3 and I will take this as a C25. This voltage is V3, this voltage is V25, and total voltage is V. What is the formula we have for this sharing of the voltages? Direct formula I am telling. V3 if I want, V3 is equals to total voltage V into other capacitor, that means C25 by total capacitance 3 plus C25, this C3 plus C25. I repeat once again, if I take this as a C1, if I take this as a C2, this voltage is V1, this voltage is V2, total voltage is V. So I want V1, V1 is equals to total voltage V into other capacitor C2 by C1 plus C2. For resistors in series, the same condition is not applicable. For resistors, what we take is V1 is equals to R1 into total voltage into R1 by R1 plus R2. For capacitors, no, other capacitor take, not the same one. So V1 is equals to V into C2 by C1 plus C2 is the formula. And for the potentials. Now what is C1? C1 is, I am taking it as a C3. This C2 is nothing but equal to this combination, that is C25, that is 2 plus 5, 7 microfarads. I want to find out this voltage. This is V25 I am taking, this I am taking it as a V3. So what is the voltage now we can get is easily. Once you know the voltage and capacitance, you can find the charge. This is we want this charge, so this voltage we want, V25 I want. So V25 is equal to total voltage into other capacitance, that is C3 by C3 plus C25, which is equals to total voltage how much, 100 into this capacitance, other capacitance is 3 microfarads by this is 3, this plus this is 7 plus 3, 3 plus 7 is 10, 10 means 0 cancels. You will get as 30 volts. This is 7 plus 3 10, no, 1 0 cancels, 10 into 3 is 30 volts. This is V25. So this voltage is V25 equal to 30 volts. This is 100, so automatically this is supposed to be remaining voltage 70 volts. So what is the charge on this? Now we can know the voltage across this is same, no? What is the charge here is nothing but equal to, I will take this as a Q5 equal to this capacitance C5 into this voltage V25. So charge on 5 C25, C5 equal to 5 microfarads is Q5, Q equal to CV, C5 into V25, which is nothing but equal to 5 microfarads, 5 into 10 to the power of minus 6 into voltage we got is 30, which equals to 150 microcoulombs is the answer. What about the other charges not asked also, we can find out by this method. This voltage is, remaining voltage is 70 volts. When 70 volts means Q3 becomes equal to V3 is 70 volts. So Q3 equal to C3 V3. Capacitance is 3 microfarads, 3 into 10 to the power of minus 6 and voltage is 70 volts, which is 210 microcoulombs. And what about this Q4? I will take this as a Q4. Q4 voltage across this is V only, whole voltage. So Q4 is equals to C4 into V, that is 4 microfarads, 4 into 10 to the power of minus 6 into 100 volts, which is 400 microcoulombs. Okay, not asked all the, but you must know how to find out that. Any capacitor asked, no, first to find out that voltage across this by voltage division method, then you can find out. Or else voltage division method is a short method. If not that, no, your resultant you have to find out. Charge you have to find out. Whatever charge here, no, same charge should be there, the total charge. Total charge. Then total charge is here same, here combination 7 microfarad also same only. This 2 plus 5 total microfarad, one capacitor same charge. Same charge means sum of these two charges is supposed to be equal to the charge on this also, because this is coming in series with this combination. You have to find the charge, then potentials here, then automatic remaining potential you will get, then you can find out the charge on other capacitors. Like that also you can do, that is left to your choice. Next 149, this 149 even last year also they asked in the Neet or KSET or in one of the examination compulsory they will ask you. Sorry, 140, 148, no, 148 I didn't discuss. 148 is a concept question, I already discussed in theory also. 148. Find force between parallel plates of capacitor. They have given data for us. C is the capacitance and V is the potential. Capacitance, V is potential. So whenever the charges must be there. Without charges there is no force. Charged plates only are taking here. Potential difference is V, means already charged to this. So force acting between them is attractive force. Both plates try to move each other due to the attraction by the unlike charges. Force you have to find out. Work is nothing but equal to force into displacement. Separation is D. Okay, so we have the formula energy is equals to work. Whatever work is done is nothing but equal to energy. We imagine that they were together, we separated. So what is the work equal to? Force into displacement, F into D. What is the energy stored in the capacitor? Half CV square. So F equal to half CV square by D is the answer for us. But the question can be asked in the different ways. Sometimes they will give you not C, epsilon A by D terms also they make you, or Q term they make you. If they give Q terms, we have the other formulas for the energies. Energy can be half CV square, half QV, or half Q square by C. Any of the terms can be given. So based on that you have to find out. Sometimes they give the terms are D terms, means we have to take is this C is nothing but equal to K into epsilon naught A by D, or K into epsilon naught A by D if the dielectric is given. This may be also need to replace. That means if they don't give C, you may have to require this terms modifications you must be able to do. Next is 149.